All right, just in case you're taking a break between reading or listening to my recordings to fall asleep, just in case you're taking a break, last time we talked about the 3 different kinds of constants. Literals look like this. Named constants start with the word private, add const, and then a normal program or variable declaration, except I use capital letters, all caps. It's just a visual clue to me as I'm writing this program that that's a constant. Can't change it. And finally, there are the intrinsic constants, the enumerations, lists of known values. And this is an example. C# knows what red means, and it gives you red, without us having to know that it's 255 parts red, 0 blue, 0 green. It knows that. Doesn't know all 2 billion colors because they don't all have names, but it knows a bunch. Why would I want to use a named constant? Why not just use the number? Because up here we said, where's my examples? Sorry. Where'd it go? There. Why not just use 42.5 in my program? Why not just use 15 in my program? Why not just use 0.05 for the tax rate? 2 reasons why we don't normally or always do that. First of all, constants are a little easier to read. If I'm trying to analyze the program, take the total sales, multiply by the tax rate, that's a little easier to understand than total sales times 0.055. Why am I multiplying by 0.055? Because it's the tax rate. So it's a little easier. So for a maintenance standpoint, this is a little easier to understand. But they also make our program easier to update. Let's say I have this very complicated point of sale system, right? And it uses the current tax rate throughout. In all kinds of formulas and 25 different methods, the tax rate shows up. If Portage County decides to change their tax rate from 0.055 to 0.06, I have to find every location of those and update them. Now, in today's world, that's not so terrible because I could do a search and replace, right? Well, kind of, but how do you know that there isn't some other 0.055 that you're going to replace that's the wrong one? To be extra sure, what we do is define the tax rate once, and we usually do this very near the top of the form, very near the top of the code so we can find it. And then if we need to change it, we change it in one place. And throughout the rest of the program, it's automatically updated because I didn't type in the number, I typed in the name. And so from a maintenance standpoint, it's one of those, the tax rate has changed, programmer. How much are going to cost me to update that? $5,000, couple of weeks. Okay? Sold. I go home, fix it in 5 minutes, take a couple of weeks off. The reason it took 5 minutes, it took me that long to find it. Right. Doesn't take long, and that's, or you go home and you fix it and go, oh, never mind, it didn't take long, it's done. Oh, you're a genius. Thank you, $5,000. No. So those are the 2 reasons. When is another question. Right? When do I use a named constant instead of a literal? Here's the question I ask myself. Could that literal value, the literal here is, here's an example, 12. That's a literal, right? The 12 is a literal. I typed it in my formula, literally 12. Could that value ever change? If the answer is no, then leave it alone. Leave it as a 12. If the answer is yes, it might change, like the tax rate. As far as I've been here 25 years, it hasn't changed. Doesn't mean it can't, could. Number of months in a year? Probably not, like it says in my notes, until we go to star dates, then things get all wacky. Then us programmers have got plenty to do. We're going to change all our programs to deal with star dates. But for right now, there's 12 months in a year, and that's not going to change. There's 12 eggs in a dozen. Later on, there's another example. That's not going to change. Unless you're a baker, I guess. Those numbers don't change. 60 seconds in a minute, 24 hours in a day. Those kinds of numbers, if you put them into your formulas, they're not going to change. You can leave the literals in there. But other things, like tax rate, can change. Looks like we might have an example of some more of these in the book on page 175, so I'm going to go there real quick and see what we got. What are two advantages of using named constants? Maintenance, both of them. Easy to change, easy to understand. Write a programming statement that declares a named constant for a 10% discount. Why would I make a named constant? Because the discount amount could change, right? Why is it 10? Because that's what it is now. For 10%. So what does that look like? Starts, how did we declare constants? Starts with the word private. And then Steve said const. 10% discount. What type? Double. Maybe a decimal. This is an ongoing argument. A discount percentage is not a money bump. It's not a money thing. It is if I'm applying it to a price. Sorta. I would go with double. So I would say double, what are we going to call the variable or the constant? Discount, all uppercase, equals 10%, right? 0.1. There is no percent. You now have to use your mathematical prowess to say, oh, they want 10%. That's 0.10. C# requires a leading 0. So if I were to type that here, I might, no, I shouldn't get an error because I'm declaring a constant. Private const double discount equals 0.10. Nice comment. Oops, semicolon. Current discount amount, something like that. Man, good thing I'm not keeping this in my code. That's an example. Why is it complaining? Good question. Invalid expression term private. Let's move it, see if that helps. Now it's happy. This is normally where I put my constants. It says this in the notes a little bit later. Right underneath the partial class statement. Right before this form bowling initialized component thing. Why? So when somebody says we need to change it, it's right there at the top. I can find it, charge them $5,000 for something that doesn't take me very long at all. I don't have to scroll through and find it. Most of my constants are always declared up here. Most. There are exceptions, but that's very, very rare for me. So that's where I would put your constants. If you need a constant, you put it at the top. Right underneath the partial class curly bracket. And it does say that in my notes. Okay, back to the book real quick. Where should you place field declaration? Ooh. Last time we talked about, I don't know if I talked about it in this class so much. I think I did in the others. These are variables, but they're inside of a method. Those are called local. I did talk about how long are these reserved? When do they get returned to the operating system, the memory? When does it get returned? As soon as I hit that curly bracket. Billionths of a second. They're called local variables. They're very memory efficient. Windows gives our program the memory it needs only as long as it needs it, and we give it back. That's why Windows can get by with a mere 8 gigabytes of RAM, because programs only use as much as they need at any given instant. Those are called local variables. We'll talk about scope in a minute. Right, but my question in the book has brought it up, so I'll talk about it. These are called local variables. They're available to a method inside that method. The book refers to methods out here, or variables or constants out here that are not inside a method as field variables. or field constants, fields. I'm not sure I like that name. I prefer class level variables. They're part of the class, the whole class. Not the method, but the whole class. This constant, or any variables that I declare out here, are available to the entire pile of methods. All methods can get at that variable. They can all refer to it. So down here, I could say that score1 is equal to, I'm just making something up, 100 times the discount. And that's legal. Sort of. Except score1 is an integer, and this is a double, and we'll talk about that, man. I'm causing all kinds of trouble here. So let's make it average, just for fun. There. Okay. The point here is not this equation. It's a lame equation. The point is discount. Where is it? It's not here. Okay, then it must be class level. There it is. From within that little black box, I call these methods black boxes in my old Air Force terminology. In the Air Force, we used to buy these black boxes from contractors. You plug a cable on this end, another cable on that end, what happens in between? I have no idea. Doesn't matter, it works. This is kind of like a black box. We could collapse it. You have really no idea what's going on inside there. But inside there are a bunch of variables, and inside here, we can see this because it's not inside the box, but we can see outside the box. So this constant is now available. The book calls them fields. I call them class level variables. We'll talk about, or constants, a little bit later. If you have some memory, some storage that multiple methods need access to, you declare them as fields or class level variables out here. So the question in the book, let me get rid of that statement down there before I forget. Where'd it go? Oh, I collapsed it. Okay, the question in the book was, where should you declare them? You should declare them right underneath the partial class statement. That's where fields, class level variables, and or constants go. Where should you put them? What access modifier should you use? Access modifier is this private. Should use private. That designates that only this form can use that constant. It's not available to my welcome form when I add it to this later. Welcome form shouldn't need it. What is the lifetime, I love this, of a local variable? These are local variables. They're inside a method. What's their lifetime? The same lifetime as the method. As long as the method is processing, those variables exist. After that, they're gone. It's kind of what we said before. When we hit this curly bracket, when I hit that curly bracket, this method is done. And so as long as the method is processing, the variables are available. But as soon as the method is done, the variables are released back to the operating system. Those are local variables. What's the lifetime of this variable? As long as the form is still displaying on the screen, oh my God, that's like forever in Windows terms. Because you've been using this form for the last 10 minutes. How many billions of a second is that? Gazillions of billions. And in the meantime, Windows is going, you still got my memory? Really? Still not done? Really? 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 Like every 10 billionths of a second, it's going, you done yet? Done yet? Done yet? Not really. Windows just marks it as used, and it stays used forever. Seemingly, until you close the form. Then that memory is released. A whole lot less efficient than these. A whole lot less. Brad, make sense? Get that scowl. Okay. One more question, I think probably answered it. No, we didn't. Write a programming statement that declares a constant for a 5.9% interest rate. Well, I got that one covered. Right there. Change the 5 to a 9 and we're done. Interest rate, tax rate, whatever. Okay, that's not a constant though, where we declare constants. I think I did that one. There it is. Sorry. Double. The book might say decimal. Again, that's an argument. An interest rate, that's a percentage. Is that a money thing? The interest rates usually are. It's a bone of contention amongst us programmers. Do you do it or don't you? If you want to be safe, you make it a decimal. Wasting a little bit of memory, but not much. And maybe gaining a little bit of accuracy. Okay. So we're back to this. When do I use a named constant? If the value could change. Whenever you type a literal, I'm going to say this about 20 times in the next 2 months. Whenever you type a literal in your program, the little hairs in the back of your neck should start standing up going, oh, warning, warning, Will Robinson, warning. You're using a literal in your program. Should that be a named constant instead? Could it change? If the answer is yes, it could change, then make it a named constant. If the answer is no, then probably leave it alone, though there's the other factor. Maintainability. Because if this is never going to change, I'm not going to be searching through my program to find all the 12s and change them because there's now 13 months in a year. It's never going to change. But if it could change, then we don't want to search and create a named constant. But remember, there's a second reason we name these things, and that's to make them easier to understand. Well, most programmers know there's 12 months in a year. So that should be, and especially since I put this comment here, that probably don't need to mess with it. But other times, we could put months in a year in there and it'll improve the readability. Maybe. Most of the time, if it never changes, leave it alone. If it changes, absolutely, make it a named constant. Every time you type literals like this in your program, little hairs in the back, particularly numbers. Not so much, you can't type date literals, those are tough. Strings, I don't worry about it too much. Numbers, if you're typing actual numbers in a formula, be wary. Should it be a named constant? Variable scope, we've been kind of hinting at it here. Local variables are declared inside a method. They're the most efficient. Class level variables go right underneath the partial class. You put a private at the beginning. If you leave it out, the default is public, and that's not good. That means everybody can have access to this and use it, and we also like to be kind of private in most of our programming, unless there's a reason to be public. And that's fairly rare. My most common public variable is my program version number. If I have a program with 17 forms on it, every one of those forms in the lower corner or on the help menu someplace displays the version number of my program. And instead of declaring it in every single one of those 17 forms, and when I need to change it, change it in 17 forms, I put it in one external location and make it public so that everybody can see it. That's an example, but we don't need anything like that anytime soon. Those are called global variables. They're available to everybody inside of this program, all the forms. You're not going to need one of those for a while. So don't even think about it. It tells you how, we'll use it later. Class level variables, particularly constants, we'll use them quite a bit. If you're not sure which kind do I use, wouldn't it be easy just to throw them all at the class level and say, here's all the variables my form needs. I don't know who needs it, but here's all the variables, and everybody's happy. Might be easier, but it's nowhere near as efficient. Because remember, all those variables are now taking up your system memory for much longer than they need to. So when you're trying to decide which should it be, the answer is easy. Make them local. Every variable is initially declared, even when I write my programs. Every variable is declared locally inside of a method. until I figure out that more than one method needs access to that variable. Then I make it field level, class level. I move it. I just cut it, paste it, tack a private on the front, done. But I start local because that's the most efficient, and then need it with one exception. Constants. I want to be able to find them very, very quickly. If there's 100,000 lines of code in this form, it might be hard to find my constant. I could do a search, but if all my constants are declared at the very top, and it's about as far top as you can get and still use it, right? If all the constants are declared here, 3, 4, 5 of them, then I can get at them and change them very, very quickly. So that's scope. Local variables, we'll be focused on those. Very few of the others. It is legal, you'll see it every now and then, to have two variables with the same name, as long as they're in different methods. Because remember, those methods are kind of like black boxes. They don't see each other. They can't see what's inside. When you collapse them, you can't see the variable. So if this class has Kevin's, no Jess's, Steve, right? And I say Steve, there's no confusion about who I'm talking about, even though in my 2 o'clock class there's another Steve. When I'm in there, there's no confusion because there's black boxes because your two classes don't meet. Now when I say Tyler, that gets all kinds of people's attention, right? But in this class it doesn't cause any trouble because there's only one. In the other classes, it causes trouble. In programming, you can't have two variables with the same name in the same scope. So I can't have in here two variables called score, score, and score. Can't do that. I can, however, come down here and declare a variable called score if I want to, or score1. There's no confusion because those two methods are never running at the same time. They never overlap. Not a problem. It is also legal to create a variable out here called score1. Whoa. How does it tell the difference between this one and that one? Depends on where you are. And this is why we don't do this, because it's really confusing. You can do this, you just don't. Every variable should have its own unique name. If I'm in here and I say score1, who am I talking about? That one. Okay. But if I'm down here, there is no Steve or score1, Steve. I'm stuck on Steve. There is no score1 in here, so who am I talking about? The one that's outside. That's just confusing. Don't do that. Every variable gets a unique name, but that doesn't mean what you Google won't use it. You might see some examples from Google. You might see some examples that your future fellow programmers will write. You go, whoa, that's confusing. But it works, and sometimes when it works, you don't fix it. Because when you fix it, it causes problems. But it's legal. And now we're going to quit thinking about it. Did it tell me to write? Oh, here it says declare a constant called games per series. Okay, so that goes under the partial class statement. So follow me here now. I'm just going to make a little bit of room. All constants start with a private. All constants, I declare all my constants class level. Not everybody does that. The number of games in a bowling series. What type of data is that? Integer. Games per series. It's a constant. You must. Watch what happens if I put a semicolon in there. You get yelled at. Say, hey, gotta give it a value. Constant field requires a value. Almost English. Equals 3. Description. Number of games bowled per night. There. Why did I make a constant? Is that ever going to change? It already has. Okay, now the professional bowlers, a series is 3 games. Okay. But for those of us who are in league, bowling's gotten expensive, especially if you're drinking at the same time. Okay? Bowling's gotten expensive. You got to pay for the shoes. You got to pay for the lanes and all, and then the beer frames and all that. It's gotten expensive. Some people, because of the beer maybe, or maybe because of the cost, stop after 2. We had our fun. Let's go home. If my league has 3 games or 2 games in a series, I could change that. Doesn't happen often, but I could. If this were my bowling program, I probably wouldn't use a constant, but I need an example in this program, and there aren't too many. Let's create another constant. Private, constant, string. The league name, the name of the league. Constant string, league name. Now that could change, right? We could decide that this year we're one name, and the next year that's a stupid name, let's change the name of the league. Equals, if it's a constant, you have to provide it a value. This is a string, so we surround it with quotation marks. C# being friendly automatically gives you the closing quotation mark. Doesn't help much, but it reminds you, in case you arrow away, you've got that empty quotation mark. And let's call ourselves the MSTC Keglers. For you non-Germans, that's bowlers.
What is it?
Bowlers. Semicolon. This is the current name of the league. And then I'm anal, so leaguer. Spell check. If you haven't installed it, do it. And what are we going to do with this? We'll play with it later, but it's just another definition, another example of a constant. All right. Variables, we use mostly local, and we store things in them. We can store dates, we can store numbers, we can store text, we can store Boolean values. Constants come in 3 flavors. Literals, there's a literal 3, there's a literal string. Also named constants, these are named constants, so that we can refer to them by name in our code instead of by these numbers or text. And then there are intrinsic constants, which we don't run into too much. Most of our variables are local, almost all. All of our constants, not because they have to be, because I like to find them, are class level. Enough theory, let's do something important here. Sequential processing. Remember, so we're doing sequential processing in Unit 4. Do this, do this, do this, do this, do this. Sequential processing, how do we do input? This has changed from procedural processing. We just use objects. Radio buttons, text boxes, buttons, labels, check boxes, combo boxes, date pickers. They do all of our input for us. We don't have to write any code to make a date picker work, to make a text box work, to make a radio button work. They just do. Good for us. Done. Next section. All right. Now, we got rid of all of our overhead here of declaring variables. Remember, that's overhead. It's not part of your design. My design says import the bowling date. We did that. And then the design says bring in text score 1, and we tried that and failed miserably. Because of this type sensitivity. This is a string. This, we declared it as an integer. Couldn't we just make this a string and make it happy? Yeah, but then you can't do math with it. We need to add these up. So what we need to do is tell C#, I know it's a string, and I know you don't like to do this. It's true, I don't like, okay, God's checking on me here. No, it's true, all right? C# doesn't want to convert it. It won't do it automatically. It relies on you to say, change this, convert it somehow. Doesn't do it implicitly. It won't do it automatically, but it knows how. There is code that has been written. The integer class knows how to parse a string. Parse means go through it one character at a time. analyze it. The integer class knows how to parse a string and say, oh, that's a number. Poof, turns it into a number. So does the double class. Ooh, look, it's a number with decimal places. Turn it into a number. These are pre-built into the language. But you, the programmer, have to designate here. This is where I give you permission to do the change, to convert. Right here. So at the beginning of this, we are creating an integer, so we use the integer parse. If you're creating a double, you use double dot parse and decimal for decimal dot parse. Int dot capital P parse. Parse is a method. What do you want to parse? In parentheses, you send it what you want parsed. And now it's happy. Hallelujah. We have to do that for every single input that is a number. So if we're getting text that's really a number, like our bowling scores, like our meters was, like your gas mileages probably will be, you need to parse them to convert them. That's what this is basically doing. So let's put a nice little inline comment here for you. Convert the string to an int. Remember a little while back in design, I said, we could do math with that text that's coming off the form. Could, but we'd have to do int.parse score text and then add to that int parse score 2, int.parse. My equation looks really gross, got all these int parse text things in it. It's terrible. Don't do it. Convert it. Now we need to do the same thing for 2 and 3, so I'm going to cheat. Copy, paste. Paste. Be careful now. Change everything. Don't just change these. See why we have test plans where the numbers are different? If I made all the numbers the same, this would pass the test. Even though I'm passing score 1 in there 3 times, it passes the test because the numbers are all the same. Doesn't matter. When you copy and paste, it's very likely you could skip a step. That's why when you do test plans, you want to have your bowling scores in most circumstances be 3 different values. This program will run. Even though I have 2 score 2s there, it'll run and it'll work. It just gives me the wrong answer. And it just sits there and grins at you like, see, gave you the answer, you happy? This is what you ask for, programmer. It can be difficult to track down. That's why we have our test plan. So now we've transferred every single input that we need according to our design. 1, 2, 3, done. It's not hard. And if you put the wrong type here, don't worry. C# will tell you. Why? Because it's type sensitive. You now have a double and you want to stick that into an integer? I don't think so. What do you want me to do with the decimal places? Lop them off. Then don't. Why would there be decimal places? C# will help you if you use the wrong type. It won't let you. It doesn't mean this code is perfect. We haven't run in a while. That will also save, so let's run. Please. Pretty please. Save the sugar on top, that's good. I type numbers in here. I better make them different because Volker said to. I can calculate. How will I know if this worked? I won't because I'm never displaying. I'm still not calculating anything. What does this say? Take what's ever in the text box, put it in here, and then quit and give all the memory back. But I can hit calculate and see if any smoke comes out of the monitor. Nothing happens. Cool. In this case, nothing is good. And we're not done yet. But what if I want to see that it actually transferred and did it right? Did I show you breakpoints last time? Little red balls?
No.
Oh, maybe. Okay, let's do it again. Briefly, yes, and we're going to continue to use them briefly. I use them occasionally to test my programs. I could just finish writing code here, right? That's 10, 15 lines. I could screw all kinds of things up. But I have a good design, so it's not likely. But by adding a breakpoint, if you want to follow along, feel free. To the left of the line number, you click and you get this little red ball. That's a breakpoint. If I run my program now, whenever the compiler, whenever I'm running and it hits that line, which is the end of my method, whenever it hits that line, the program will pause and let me look around. You don't have to do anything special. You just run, put some stuff in here, and calculate. And as soon as it hits that curly bracket, it pauses. The yellow arrow designates I'm paused here, and we can look around. What's in here? First of all, notice it says that in that text box, there's a string. See the quotes? 111, cool, that's what I typed. How about this one? 222, that's what I typed. How about this one? 156, they're all text, they're all strings. But now these have already been processed. If I touch these, oh cool, it turned the string 111 into the integer 111. And I've tested, and sure enough, that works. What if let's stop. Let's do that little error thing that I had. Let's do this. 2. Okay, and then we go up here, and this is a good test. 1, 2, 3. Go. 1, 2, 2. Uh-oh, there's my first clue, right? Or I could go over here. 1, cool. 2, 3. 2. What? What are you? 2. Oh, geez. And then maybe you see it. Okay? Or you stare at it for 15 minutes and you go, I don't see it. You send it to me, and I go, hey, why are you doing score 2 twice? And you go, oh my God. Why didn't I see that? Because you've been looking at it too long. Let somebody else look at it, like me, or the person sitting next to you. You could lean over and say, can you see what's wrong with this? I'm getting the wrong values. Once you're done with the breakpoints, click it again to remove them. So this is working. It's converting text to numbers. You must do that. We cannot do mathematical equations with text. So now we've done it. Here's another example. Take the age, convert it into an integer. But let me show you a couple things. What if I leave them blank? That's the equivalent of smoke coming out of your monitor. It's called a runtime error. And if you look at this, it says this, I have an unhandled exception. An exception is an error that's unhandled. What does that mean? It means we didn't write code to deal with it. We will. And underneath it gives us a little more additional information, which is a whole lot more valuable than that. Input string was not in a correct format. Int.parse has its limits. It knows how to turn numbers into integers. But I didn't give it a number, so it went, can't do that. Hit stop, it'll all go away. Run, and how about that? Probably not. Smoke. It's good to know. Int.parse, double.parse, decimal.parse, none of them like text. None of them like nothing. Ew. It's kind of rough on us, isn't it? Yeah, but we'll learn to deal with it soon. And then learn how to deal with it properly next semester. By the way, commas, decimal places in an integer, You're getting smarter already. If I run this program and say 1.5, you'll go, that's not an integer. Int.parse is going to look at that and go, oh, I'm sorry, I don't recognize it. Other languages, they see the decimal place and they quit and they go, 1. It's not what I typed. No, it's not. But they did the best they could. In C#, it just throws an exception when you do that. And notice the error is always the same. Input strings, not the right format, not the right format, not the right. Can you give me a little more detail? What was it you didn't like? No. Not doing it. So Commas in your numbers, not good. Dollar signs, nope. Percent sign, nope. In C#, in most programming languages, numbers look like digits, decimal places, and maybe a minus sign on the front for negative numbers. But that's it. And the parse routines don't know what to do with the stuff that you give them that isn't good. But they do something called throwing an exception. They send a signal back to your program saying, I'm sorry, there's something wrong here. And we can catch that. It throws the exception. We're going to learn to catch it later and deal with it in this unit, but a little later. So for right now, just recognize that you must type valid values in there. If you're following your test plan, you should be okay until you get to test plan number 5, where we threw it a curveball and said it should do this. Actually, no, we don't want it to do this. We want it to error gracefully. This is the box that the user sees if your program does this. I don't want to show them that big ugly box. I don't want them to see that. We're going to intercept it later. So for right now, I'm just stopping my program. And I'm going to feed it good data from now on just because I know it's going to crash. That's normal right now. Oh, there's another checkpoint. Let's go take a look. What page was that? Missed it. 151. Going backwards in time here in the book.
49. 149.
Oh, 149. That's right. No.
All right, since you guys can't decide, 151. There's more checkpoints all over the place. I'm not following the book's order here because I think my order makes more sense, but that's me. What method converts the literal 40 into an int? What?
Parse method.
The parse method, good answer. Int.parse is more accurate. Little int dot capital parse. Write a statement that converts each of the following. This is dumb. Why would I, in my program, type a string that says 9.05? Why would I even type that in my program? Never. This is much more likely. I have a variable called grand total that has a string in it. That's a stupid name for a variable. I can parse variables. You don't do it very often. Normally you parse text box input strings. So this one makes sense. The others I think are stupid questions. Because this would be int.parse and in the parentheses quote 50. If I want the integer 50, why don't I just do 50 instead of parsing the string 50 to make 50? No. This makes sense. Int.parse parentheses price text box dot text. Parentheses. Take what's in the text, that's a string, turn it into a decimal. So I didn't say integer, I'm sorry. Decimal.parse. Can I, why would I take the 50 and parse it as a decimal? Because it's an integer, right? And it'll parse that and turn it into a decimal. It'll say, oh, I recognize that. You don't have any decimal places, but I can take care of that. You don't have an M. I take care of that. Me personally, 50M. Done. Goofy questions. Suppose the application has a decimal variable called total and a label called total label. What happens when I do this? What type is that? It says it's a decimal, right? What type is that? String, because it's a text property. It's always string. This says put a double in a string. I don't think so. I'm racist. I'm sorry. Prejudice. No, I'm sorry. Type sensitive. They don't match. But we haven't learned how to solve this one yet. The reason we haven't learned how yet is because it's output. We're still doing we haven't even done calculations yet. This is an output, right? Put it in a label. Write a statement that displays these. No, that's output. Write a statement that will store the value of an int named result in a label. No, that's output. Later. No dollar signs, no percents, no commas, no spaces in your numbers. But users like to type commas. They like to type percent signs and dollars. Yep. So we're going to have to learn to deal with that. And we will. Inside our program, we don't use any of that stuff. No commas, no dollar signs, no percent signs. Everything is just pure numbers. So we have to do some work. I have written, there's nothing built into C# that says, here's a string, it may have dollar signs and commas and stuff in it, deal with it like a number anyways. I've written a piece of code called Unformat. What Unformat does is strips out, very quickly, all the dollar signs and commas. And I think I even made it smart enough, if there's a percent sign, to take the percent sign off and divide the number by 100 when you're done. Because it probably says 5%, which is supposed to be 0.05. That's convenient. And I'm going to share it with you. Cool. Because it's so common. Users type dollar signs, users type commas. Unformat says strip all those out, then try to parse it. And I'll show you how to use that later. There's a link because it is in these notes, but later. That's a little too complicated for now. Text boxes cause most of the trouble. When you're using date pickers, that's not a problem because this is already a date time, right? So we don't have to convert it. It's only when you're using text boxes to collect numbers that we have trouble. If we're reading in somebody's name from a text box, that's a string. What are we going to put it in? A string. That matches, no problem. It's when they're numbers entered in a text box. Here's a numeric up-down. That's the look out with the arrows where you can click the arrows to make the numbers go up and down. This you don't have to convert either. The number of kids, grab the value from that numeric up-down and stick it in this integer. Oops. That doesn't work. The numeric up-down is more flexible than integers. The numeric up-down actually returns a decimal. So it'll take big, huge numbers that go up by millionths if you wish. But every time you click on the arrow, it goes up by a millionth. Don't do that very often. So the numeric up-down actually returns a decimal, and I said here, this is a decimal, stick it into an integer. Decimals are huge, integers are small, I ain't doing that. So this actually is an error. You have to use a special technique called typecasting. What this says is take whatever this is, and I, the programmer, give you permission to turn it into an integer. Notice the way it's written. The int is surrounded by parentheses. In most languages, the parentheses are around the number of kids' value. This is backwards to me in C#, but that's the syntax. This says take this, whatever it is, turn it into an integer, then stuff it into an integer. That's cool. But what does it do with the decimal places? Well, there probably shouldn't be any. Maybe there's a number of kids, right? Why would there be any decimal places? You can format the numeric up-down to just do whole numbers. But they look like whole numbers, but they're still decimals. And so I, the programmer, say, I promise I'm never going to yell at you, program, because you stripped off the decimal places, because there ain't going to be any. I know, because I'm smarter than you are. I'm the programmer. Go ahead and convert that decimal to an integer. C# knows how to do it, but it needs your permission. It literally lops the decimal places off. Does not round, doesn't do any of that stuff, just lops them off. Let's take about 30 seconds to look at those checkpoints at 138, and we'll call it good for today. Specify the appropriate primitive data type for each of the following. So what type of data? Primitive, what is that? Decimal because?
It's money.
Because it's money. No more answers from Joni. Bananas. Integer because I guess we're not selling half of bananas. My house, granddaughters, lots of half bananas laying around. But that's an integer there. Inches. Double just said no more answers because it's got a decimal place, but it's not money. 83 cents. Decimal because it's money. Even though it's a small amount of money, we want to be accurate. And how in binary do I represent 0.83? Oh, that's nasty. 2 concert tickets, integer. Okay, not too hard. Which of the following will cause an error? Look at those 4 and tell me, there's only one.
The integer.
Which one?
Baby.
B, because that's not an integer. M means decimal, decimal, double, double, string, string. That's a decimal, or that's a double, excuse me. Because why is that a double? Because that's the rules in C#. Anything with a decimal point on it, any literal with a decimal point is a double, unless you tack the M on it. Where's the decimal places? Don't need any. This is 24.0, technically. Write a programming statement that converts the following decimal variable to an int and store the result in int. Name $. Oh, interesting. I'm going to take deposit and turn it into an int. How do I do that? I'm going to the board. I'm going to try to say it loud enough that it hits the recording. All right. We have a deposit variable. And when I draw variables, I usually just draw a box. And inside here, I have, what's the magic value? 976.54. 976.54, and by the way, this is a decimal. You can almost read that. Now, the assignment says, put that in a variable called dollars.
Yep.
Dollars. That is an integer. I can't take this and put it in there. This is a decimal. It takes up 16 bytes of memory. The number of bytes isn't important, except to know that this is bigger than that, because that's only 4. I would take 16, put it into here. Using an equation, I want to say dollars, and I usually do a separate command, int dollars to declare it. We could combine them like they did here. It says int whole pieces equals. So they're declaring it and assigning it something at the same time. That's fine. Not a big fan of it. Dollars equals deposit. Semicolon. Illegal. Decimal. Integer. I'm the programmer. Shut up and do it. Parentheses int in front. This says take whatever that is, convert it to an integer, then stuff it into here. I give you permission. That's what that says. What value will be in whole pieces when we're done with this? Whole pieces is 6.5. Turn it into an integer. What do we get? 6. Lop them off. If that was 6.999999901, 6. It lops them off. No rounding. What if I want it rounded? That's a different problem. First of all, why am I changing it? Is it a double or is it an integer? Which is it? You don't usually change things too much, but occasionally. So that's an introduction to typecasting. I'm changing this. Does this statement here we use the most, otherwise the recording's gonna be a little nuts here. Does this statement permanently change total pieces to an integer? No. It simply says, for the purposes of this equation, make this an integer. It's an integer. If I come down here later, total pieces is still originally a double, it's still a double. This is just a temporary change. We'll talk more about that on Friday. See you then.